Okay, so last time we have completed all these things. Remember this OSPF neighboring condition and multiple way to configure
Yes.
OSPF, right? Okay,
Yes.
and today we are going to work with OSPF multi-area configuration. Means if you have multiple area connected with, okay, like if you have different area connected, how they will be communicating. Okay, so here we have this lab. So let's open this
Okay.
OSPF. Okay, multi-area. Okay, so now you know the basic lab. First you have to configure IP address, then you have to configure routing. So let's start all the labs. Okay, and then take a console.
Yes. So here you have already. Okay, I thought you have already configured the IP address.
Maybe I will check because in some lab I think IP will be there, but we will just will verify. Okay, so we'll come here to R1, R2, R3.
Okay.
Okay, PC1, no IP address. So we will configure IP here, IP 192.168.10.1/24 and 10.10 as a gateway. PC2, R1. So IP interface brief, I think interface is there, E0 by 1. Okay, no problem. So conft interface E0 by 0 IP address is 192.168.10.10.255.255.0 no shut, then interface loopback 1 IP address 1.1.1.1. Okay, and then so interface brief exclude on sign. Okay, all IP is there, right?
Yes.
Okay, we'll save it. Now come to R2. No IP configuration, so conft interface E/1 IP address 12.1.1.2. Interface E/2 IP address is 23.1. Okay, now R3. R3 has 3 interface. No
Yes.
conft interface loopback 1 IP address is 3.3.3.3. Then interface E0 by 0 IP address 192.168.20.10. Now shut. Then interface E0/2 IP address will be 23.2. Now shut. Okay, IP configuration is completed and we verified yes, all is up. Now it's part of these PC configuration, right? IP
Yes.
192.168.20.1/24 92.168.20.10. Save. 3.2 save. Okay. Now we will configure the routing. See here. So R1 is have two interface, right? If you can check here, R1 have two interface, and
Yes.
all these interfaces are connected in area 0, right? So R1 will advertise their networks in area 0. You have
Yes.
to come here simply conf t,
With area one, area
yes,
zero,
router
zero. Yeah.
ospf1, router id 1.1.1.1, then network 12.1.1.0, wildcard
Okay.
mask, and then area 0.
Area zero.
Yes, and then 192.168.10.0 wildcard mask, area 0. Exit.
Zero.
Okay. Now we will come to R2. Router OSPF2, router ID, okay, 2.2.2.2,
Without,
network,
uh,
two interface, right? One is area 0 and one is area 1, right?
area one.
So I'll first come to
Yes.
23.1.1.0,
Yes.
okay,
Area one.
area 1, and then network 12.1.1.0,
Area zero.
00003, area 0.
Zero.
Yes, then exit. Now come here to your R3. Once here neighborship came up, and if you are coming here,
Yes.
config router OSPF3, router ID 3.3.3.3, and then network 192.168.20.0.0000255, and then area 1, right?
Okay.
And then here we forget to advertise one more, network 3.3.3.3,
Okay.
area that, and one more is remaining, 23, 23, area 0. Exit. R1 we forget to advertise loopback 1, right?
Yes.
Network 1.1.1.1.0.000, area 0. And now if you're coming here, R3, sorry, R1. If you're on R1, you can check here. So IP route, yes, route is there, but you are getting route as OIA, right? Okay, OIA
Yes.
means you are getting these all information from different area.
With the area.
Yes, inter
Yes.
area, different area. And if you are on PC1 and if you are trying to communicate 3.3.3.3, yes, no problem, you are communicating. But now tell me R2, if R2 will check so IP route, see R2 is getting as a O, not OIA, because R2
Yes.
and yeah, both
He's,
interface is connected in both
uh,
area, right?
he's in the middle, so.
Yes. Here also if you will come, so IP route, you can see here OIA means OSPF inter area. Okay, OSPF
Yes.
inter area. Okay, now you said okay, this is okay, no problem in this. Okay, now Okay, this we will talk later. Okay, or you can talk. This is important to know. This one, like
Okay.
if we have some OSPF configuration like this, right? Okay,
Okay.
so what are the roles of OSPF routers? Okay, means like which router will be known as what? Okay, now understand here. Here you will have like you have some routers which is connected inside area 1, right? Okay, so
Yes.
these routers will known as an internal router. Okay, and these area are known as regular area. Okay,
Okay.
regular area. Okay, now
Okay.
the router which is connected to two different area, like see here it is, this router is connected in area 1 and area 0
Yes.
also, so this router is known as area border router.
Yes.
Okay, now again you have some routers which is inside area 0 but it is not connected to other different area, right? It is simply
Yes.
connected to area 0, so this router is known as border, sorry, backbone router.
Okay.
Okay, now again this router is connected in two different area, area 0, area 2, so this is area border router. Again I have two router
Okay.
here, router 6 and router 7 connected to same area, area 2, so this is known as internal router, and this area 2 again it will be known as a regular area.
Okay.
Okay, fine.
So the middle one, the one that you write beer, the border router.
No, 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 backbone router.
Backbone, yeah. Backbone, okay.
Yes, backbone router means the router which is inside area 0.
Okay.
Okay, now one concept will come here that okay, now if we have area like this, for example, if we have area like this, area 1 and area 2 without area 0, do
Okay.
these area will be able to communicate?
Okay.
Let's try. Okay,
Okay.
so our IP configuration is already there, we just have to remove OSPF, come to router 1,
Yes.
conf t, router OSPF 1, no, we'll come to router 2, conf t, router OSPF 2, no, we'll come here to router 3, conf t, router OSPF 3, sorry, no. Okay, now let's verify 2 so IP protocol, no protocol running. Okay, you can check
Yes.
here also, no protocol runnings, no protocol. Okay, now we are coming to again area, sorry, router 1. In this we will be configuring like that, conf t, okay, we are there, router OSPF
SPF one.
1, router ID 1.1.1.1, network 0000 0000, area 1, right? Is it okay? No problem.
Yes.
Okay, let's come to
Yes.
router 3, router OSPF 3, router ID 3.3.3.3, network 00000000, and then area 2.
Two.
Is it okay? Okay, now
Okay.
here we are on R2. R2 will say router OSPF 2, router
Yes.
ID 2.2.2.2.2.2, network
Okay.
12.1.1.0, 00003, area 1, right? No problem.
Yes.
Okay, and here network 23.111.0.0.0.0.3, and then area to
Two.
exit. Now see, neighborship came up. Now if I'm on R2
Mm-hmm.
and if I'm checking here, so IP route OSPF, all routes is there. See, R2 is getting network from
Yes.
R1 as well as from R3 also, right? No
Yeah, three.
problem. Now if
Yes.
R1 wants to communicate 1.1.1.1, yes, ping 3.3.3.3, no problem, right? Now but if
Yes.
R1, if you are coming
R1.
to R2, sorry, R1 and checking this, so IP route, okay, are you getting any OSPF?
No, no, nothing.
Nothing. Now if you are coming here to R3 again, so IP route, okay,
Nothing.
nothing is there, right? So what you have to do, that's why whenever you want to create communication between two different area, okay, so the
Yes.
area 0 must be as connected as a transit
In the
area
middle.
in the middle.
Yeah, it's
Yes,
in the middle.
yes, okay.
Yes.
Now but if the connection is like this, right, do it will work, right? See, even if you'll come to R3 and check one thing, so IP OSPF interface, or so IP OSPF, see, okay, I'm OSPF with my router ID this, so IP protocol,
Area two, area two.
okay. So here on R4 we have
Okay.
configured and we saw that neighborship came up, right? Now let's come to
Yes.
R5 conf t interface. R5 has four interface, right? Two in area 2
Yes.
and two in area 0. So interface E0 by 0, IP
Zero.
address is 55.1.1.1. Here no shut, then interface E0 slash 1 IP address is 57.1.1.1, no shut, and then interface E0 slash 3 IP address is 45 to no shut, and then interface E0 E1 slash 0, right? E1 slash 0. IP address is 35.1.1.2. No shut and do write. Okay, and then exit, and you can say here router OSPF 5, router ID 5.5.5.5, network we can say 56.1.1.0, 3 area 0, no problem. 57 also area 0. But when we are talking about network 45 0, which is area 2, and 35 also area 2,
Zero.
okay, 35 45 area 2, and
Yeah, area
56
two.
57
Area zero.
area 0. no problem. Okay, fine. Okay, now R6 conft interface loopback 1 IP address 6.6.6.6, then interface E0 by 0 IP address 56.1. Okay, 56.2, because 1 we have assigned on 5, right?
Yes.
Then no shut, and then do write, and here we can simply run router ospf 6 network 0 0 0 0 0 0 0 0 and area 0. It's it. Now if we are coming on R7 conft interface loopback 1 IP address 7.7.7.7, then interface E0 by 0 IP address 57.2.252 no shut, then do write. Okay, and then router ospf pf7 network first router id 1.1 7.7, sorry, 7.7.7.7, and then network. See here you can advertise like this also, 00 or like 255 instead of writing like that. Okay,
Okay.
and then area 0, no problem. Now wait for the neighborship. Now see R1, let's we'll R1, if you check here, so IP ospf neighbor, R1 has only R3 neighbor. Okay, fine, no problem, right? Now R3,
Okay.
R2, R2 will check, so IP ospf neighbor, no neighborship. Now we have to check what is the problem,
Yes.
right? Maybe we have configured wrong IP
Yes.
or what. 20 R3 34 35 23 13 is 0 by 1. Okay, no problem. Verify. So IP interface brief exclude on set. Okay, we have 4 interface. So we have 13,
Three.
23 is not there, right?
You have three interface.
Yeah, interface E slash. Okay. I have configured wrong IP addresses. See here. You can see here E0 E1 slash 0 is 35. So no problem. I will come here interface
Yes.
E1 slash sorry,
Zero.
first is E0 slash 1. Let's change that one. E0 slash 1 IP address is 23.2
Okay.
255.255.252. No shut, then interface is E1 slash 0 IP address
85.
35.1.1.1 252. No shut, and then let's save it. Okay, we'll see the neighborship. Now R2 have neighborship now. Yes. Okay, now R3. R3 should have 4 neighbor, right? So
Yes.
IP OSPF neighbor. 4 neighborship, good. All is
Yes.
okay. R4 will have 2 neighbor. So IP OSPF neighbor, 2 neighbor. This is also okay. See, you have to verify the, see why we are verifying. because this lab is little bit bigger, right? Yes,
Yes.
so IP OSPF neighbor, all is okay. So IP OSPF neighbor R6 is a problem. Now what is problem? R6 should have neighborship with R5. Now R5
Yes.
should see R5 should have four neighbor, but only
Have four neighbors.
yeah,
Yeah, we
only
can see
three and four is neighbor.
even two.
Yes, three and four, but no five, no six
No
and
five,
seven.
no six.
So let's verify
No
the
six
IP
and
address.
seven.
So IP interface brief exclude unassigned. 55 wrong IP. Here it should be 56, right?
Yes, but we put
Okay,
55.
so no problem. Will come here. Interface E0 by 0. Interface E0 by 0. IP address is 56.1.1.1.
Yes.
No shut. Now wait for the neighborship. Neighborship is okay. Now
Yes.
57. This is okay. No problem. R6. So IP OSPF neighbor. This is okay in one neighbor. And R5 neighborship is 3 now. Only R7 is the problem. Now what is the problem? So IP OSPF neighbor, no neighborship. So IP interface brief exclude unassigned. 57 to E0 by C here
Here
E0.
it is E0/1.
Yes, so interface E0 slash 1 IP address. So first we have to go there to
Yeah.
interface E0 by 0. No IP address.
IP address.
Yes, then we
Yes.
will go to interface E0 slash 1. Then IP address 57.1
Dot one dot one dot
1.1.2
two.
255. No, sure. See, we there was a problem in the lab, and when we rectified, we
Yes.
troubleshooted it, right?
Yes.
Yes. So now everything is okay, and if you check here, so IP OSPF neighbor, yes, neighborship is there, and R5 will have now four neighbor. Okay, all is okay.
Four.
But
Yes.
now if you are on
Yes.
R5, okay, so
Yes.
R5 is a border router, so you will have how
Yes.
many networks? Check here. So
Four.
IP OSPF, sorry, so IP route OSPF 6734.
Okay.
Yes, 6734. See here, 6734. Why? Because these are connected. So I checked only this one. But
Yes.
what about 13 and 23? Is not there, right?
Yes. Yes.
Okay. Yes. So this is the problem. And if you'll come to R1 and if you'll check here, so IP route. See, only one route. Okay, which is
Yes.
23.
23.
Yes, only this one, 23. This one, which is in the same area,
Yes.
but not from different area, not from this one. So why this is a problem? So I told you, this is the OSPF rule, that whenever you want to create communication between two different area, that area 0 must be there.
Yes.
Okay, but maybe, like the engineer have has configured like this. Okay, and
Okay.
you came, so you cannot come and reconfigure everything, because networks are connected like that, right? So what is the
Yes.
solution for that? So now see here. An area border
Yes.
router is a kind of a router that is located near to border between one or more open shortest path first area, right? OSPF area. It is used to establish a
Yes.
connection between backbone network and OSPF regular area, right? That's why we use ABR. Now,
Yes.
now, but if you have connected like this, if ABR, see this ABR is connected to area 0, right? But do this
Yes.
ABR is connected to area 0 direct connectivity? No,
No.
no. So what you have to do, you have to create one virtual link. So what is virtual link? A virtual link that interconnects the backbone area with an area that is not adjacent to the backbone area, means that area which is not connected to area 0. We configure the
Okay.
virtual link between ABRs means this ABR, which ABR? The ABR which is connected to area 0 and the ABR which is not connected to area 0. See, now tell me who is responsible to create communication between two different areas? This ABR router, right?
Yes.
Now,
APR,
this
yes.
ABR
The
router,
one that is connected, yes,
yes. Now
to the
this
area zero.
is this router is okay. He's saying that yes, I am okay. I am connected to area 0. So if you will come to me, I will help you to communicate to area 0. No problem. Like R4. If
Okay.
you are coming to R4 and
Okay.
if you are checking here, so IP route. See, R4 is getting all this 6, 7 network. No problem, right?
Yes.
So is ABR is saying that if you will come and connect to me, then I will help you to communicate, right?
Okay.
Because I'm directly connected to area 0.
Yes.
Okay, but this ABR is saying that if you will come to me, I will help you to communicate, but I am not connected to area 0. Direct connectivity, always keep in mind, ABR must be directly connected to area 0. It's not that okay, my friend is connected, my friend will help me. It's not like that. Okay.
Okay.
Okay, so what will happen here? Here you have to create one virtual link between R3 and R5. So R3 will receive the request from here. Okay, R3 will forward those requests from R3 to R5 and R5 will help them to communicate. So you have to create a virtual link, means virtually
Okay.
R3 will be connected to area 0. Okay, so here is saying that we configure a virtual link between ABRs. ABR means one ABR to another ABR. Okay,
Okay.
and we use that area virtual link, means like we use virtual link command to create. And which area, like which ABR? The ABR which is not connected to area 0 and the link is going to that ABR which is connected to area 0.
Yes.
Okay,
Yes.
now understand what is OSPF virtual link. So a virtual link is not a physical link, it's a logical link using the least cost path between ABRs, okay, of the non backbone, means non backbone, which is this one. Non backbone is what? This is non backbone, right? This area is what?
Yes.
Is not connected, means this area ABR is not connected to backbone area, right?
Yes.
Okay, so this is also non backbone connectivity, this is also non backbone connectivity. Okay, non backbone connected area and the backbone ABR. Who is backbone ABR? This is backbone ABR. Okay, backbone ABR means this you are connected to area 0, that's why you are backbone ABR of the transit area. Transit area means the router which is connected to area 0. Area 0 is also known as backbone area and transit area. Now a virtual
Okay.
adjacency across the virtual link is formed and routing information will be exchanged. Like see, area 0, area 1, area 2, right? See, then see, can you see here? This is what? ABR, this is also ABR, and
Yes.
then there is a
Yeah.
virtual link, and then all the data will be exchanged. Now, how to configure? It's very easy, okay, and it's not tough. Like see, if you have to come to area 3 and area 5, okay, and now see how to configure. I'll come to area 3 and area 5. So first you have to come to area 3 and you have to say that router OSPF 3 your process, router ID which is your ID like what we are using here 3.3.3.3. Okay, now you have to say that I am like your ABR, you are ABR, right? You are ABR, right? R3 is ABR and the R3 is trying to communicate to the another ABR, right? And that ABR is connected, the both ABR is connected in which area? The both ABR is connected in a area 2.
Area 2.
Yes.
Yes.
So you have to say that area 2 virtual link. Okay, what is the router ID of R5, which is on that ABR? Is like that. Simple command
Okay.
and then type end. Now same thing you have to come to R5.
Okay.
Conf t. What we are getting some message invalid, received invalid packet mismatch area ID. Okay, we are getting now, maybe after. Okay, then here you say that router OSPF 5 router ID
Okay.
5.5.5.5, then area 2. Okay,
Okay.
virtual link. I want to create virtual link between 3 and then end. Now see, neighborship came up. Can you see here? Neighbor 3.3.3 on OSPF virtual link. Okay, and
Yes.
once the
Zero.
neighborship came here, see here, neighborship came up. And once the neighborship came here, and now if you'll check, see, all is there now. See, all network came.
Okay.
So whenever you have any connectivity like that and there is a problem like, okay, so in that case you have to create virtual link. Now you will say that, okay, if there is one network, maybe if some engineer will create like this.
Okay.
Okay, maybe any engineer will say that, okay, let me create one area here like this. Another, this router will connect to one router. Okay, and here you
Okay.
have one area which is area 3, right? Okay, so this
Okay.
router will be known as what now? Tell me. This router is now connected to area 3. Okay, here is R2
Area
here.
border out also.
Yeah, this is also area border router, but do this area border
Yes.
router is connected to area 0?
No.
No. And you want to create communication, so what you have to do, you have to create virtual link.
Between this R2 and the ABR which is connected to the area 0.
No, this R2 to this ABR,
Okay.
and
But this one is still
this area
connected.
is connected to this one.
Okay, so
You
you
cannot create
join this
communication
link.
directly like this, because
Okay.
ABR to ABR virtual link must be in a
Okay.
same
Same
area.
area.
Yes.
Okay. So if it's like this, you have to create the connection between the R3 and R5, and then later you have to
Yes.
connect. You have
R
to create the
R2 and
connection
like
between.
R8, something like that.
Okay.
Understood?
Yes. It's good.
And now if you are coming here to this R3 and checking interface, you'll find one virtual interface will be there. So IP interface brief. Let's see. Uh, so IP OSPF OSPF virtual link. Okay, see about the virtual link information. See, R3 is connected. See, the virtual link is, this is your virtual link which is connected to R5 and the status is up.
Yes.
Okay, but which interface
Yes.
is carrying, means carrying your data? So this interface E0 E1/0 is,
Yes.
yeah, is, see, this E0, this is connected, because see, unfortunately you are, the data is carrying by the interface, right? You are, okay, your your
Yes.
data from R3 to R5 is passing through E1/0, so it is there.
And same information if you want from the R5 you can get it. Okay, R5 also. But if you check this same information like from other routers, you will get said that it's not there. See. So only
Okay.
interface, virtual interface, which is working there, and see state is point to point.
Up. Point to point. Yes.
Yes, virtual link is point to point you have created.
Yes.
Now, now we okay. Now we have to work with OSPF LSA.
LSA.